Everybody for attending the webinar. This is the third in a six-part series of webinars. The first two webinars that we've done looked at how to write code with the RStudio IDE and also how to debug the code that you write. So now you can use those webinars to write polished, finished code. And what we're going to look at today is how you could share that code with your colleagues and collaborators should you want to. We're going to share that code by writing a package, something that the RStudio IDE can help you do. You'll notice how we're going to take a few weeks off, and when we come back at the start of the new year, we'll look at 3 more webinars that cover the project system in RStudio, version control, collaboration, and some reproducibility tips with the PackRep package, all centered on using the RStudio IDE to implement these things. If you missed the first 2 webinars and you'd like to watch recordings of them, or if you come later and would like to watch recordings of this entire series once it's finished, you could go to this web address here. So today we're going to look at how to write packages, and a good place to start is to ask, what is a package? A package in R is just a collection of functions, data sets, and help pages for those functions and data sets. If you're using R, I'm almost certain that you've already used a package because they're so essential to the R workflow. You've probably downloaded packages from the CRAN repository and installed them in your local session and used them. For example, if you use the knitter package or dplyr or ggplot2. But you might not have considered writing your own packages. And today we're going to take a look at what that would involve. Writing your own packages in R is a good idea if you're already sharing data sets with colleagues or functions or just emails that describe how the code you've written works. Writing packages is a good idea because the package system in R is the fundamental way to transport code with R. R is designed to use packages. R knows exactly what to do with a package, and R makes it tremendously easy for your users to access and use your code if you put it into a package. And you don't have to share your package with the world. You don't need to put your package on CRAN or anywhere else. You could keep it within your company, within your research team, within your department at the university. No matter what scale you're sharing code on, a package is a great way to do it. And on top of all that, writing packages is fairly easy. And even better, there's a lot of documentation out there that can help you write packages. Specifically, the book R Packages, recently published by O'Reilly Press, is written by Hadley Wickham. Hadley is a veteran R package developer. He's written over 30 packages. He's put together this book that describes every detail of the process and minutia using his experience writing a tremendous volume of packages. You could read the book for free online, the entire thing, by going to this web address. And then if you'd like a hard copy, you could purchase one from O'Reilly Media. I'm going to refer to this book at several points during the webinar because we're not going to have a chance to get into every detail of our package process. We're going to look at the general outline and how the RStudio IDE supports that outline. So let's get started. In the previous 2 webinars, I used a version of the RStudio Server Pro, but today I'm going to use my local desktop copy of RStudio. And that's because I have some local files that I think would make a fairly interesting package. The first file is a data set called centralflora.csv that I've collected just by going to different parts of the internet and typing data manually. It's not very big, but I find it interesting. And I'm going to use RStudio's import dataset feature to import this data set. I'll save it with the name CFL, nice and short. This data set has headers, and then I never like strings as factors. This is what the CSV file looks like in the raw form, and this is what it'll look like once I read it into RStudio. Now we could take a look at it, and you see what I've done is I've collected information about 50 small towns in Central Florida, things like the per capita income of the town, the median age, that sort of thing. I've also written some functions that can help me really dig into this data. The first function is called City Selector. It's a bit long, but I think it's kind of impressive. It builds a Shiny gadget, which is a specific type of Shiny app that can let me really analyze this data. The City Selector function requires 2 helper functions, one called mapviz and one called interval scale. And I've written those and I save them here in this mapviz.r file. If we source these files, we could try these things out and see exactly what they do. So City Selector is a function that opens a Shiny app. We call this sort of thing a Shiny gadget. When I type in City Selector, it doesn't require any arguments. It opens this app that I've created. And here we see a map created with the mapviz function that displays all 50 small towns in my data set on a leaflet map of Central Florida. So I live in Central Florida, and at the moment I'm just renting my house. But I might one day like to buy a house, and so exploring the cities nearby is a good idea. It might help me narrow in on where I should look for houses, should I follow that path. At the moment, All of the houses are displayed with a single black circle. But I've included sliders down here for every variable in my data set. And I could use these sliders to weight the different variables in the data set to score each of the cities. For example, if I were to move somewhere different, all things considered, I prefer a place with a low cost of living. So I might weight the cost of living variable negatively. You see, the app immediately responds. The size of the cities that have a low cost of living increases over in the map, and then the table up here for top cities reorders itself based on the score that each city gets according to, at the moment, just the cost of living variable. But I'm also interested in other things. For example, I really don't like violent crime, and I'm not a big fan of property crime either. So I could go through here and weight each of the variables, positive or negative, and partially in either direction, to create a scoring function. The map helps me zero in on a set of cities, and the table shows me the top cities. The reason this function, or this app, is a shiny gadget is because once I've developed the scoring function that I like, I could click this button, Get Scores. It will close the app, and it'll take whatever the current scores are for the cities and return them to me as a vector. So when I do that, the app closes, and here's my named vector of the scores for each of these cities. Now, I didn't take the time to save it to anything up here, but you can imagine I could do something fancy like CFL, and then I'll pick a new variable called scores, and I could save right into it the output of my shiny gadget. So it's a great interactive way to do something. Now when I save these scores, they're immediately saved into that variable. So yes, this won't be interesting to the entire world, but maybe there's enough R users in Central Florida that they'd like access to this function through an R package. So what I'm going to do is I'm going to turn these two scripts and one data file into an R package. In fact, to be honest, I've already done this. I have a package here called City Selector. It's the R package that contains these files. It's already installed on my computer as City Selector. And if I wanted to, I could load it with, City Selector, the way I'd load any package. And then I could start using the different functions in it. So that's the goal. And I'll actually look at this package at a few places during the webinar to save us some time. But for the most part, I'm going to start again from scratch and rebuild it just from those raw data files. So like I said, we have three files, MapViz, City Selector, and this data set. I want to turn them into a package. So how can I do that? In R, a package is just an agreed upon file structure. When R downloads a package, it expects the package to be organized in a specific directory structure. And as long as you organize your files in that structure, the package is going to work with R. Give or take some details you have to take care of. You can create that package structure very easily in the RStudio IDE by creating a new project specifically associated with your package. So I'm going to go to File, New Project, save this current one I'm working on. I'm going to put this project in a new directory, and I'm going to tell RStudio right here that that directory is going to contain an R package. So I click R package, and then since I've already written some code that I want to appear in this package, before I click Create Project, I'm going to add the code I want to appear in the project. I'll click the Add button. The code I want to add is the City Selector file, and then I'll also add the MapViz file. I'm not going to add the data set because that's not technically code. I'll show you how to add that in a second. Let's pick a name for our package. To keep things straight, let's just call this Demo Package. Now when I click Create Project, RStudio opens a new project. I'm now working in a new working directory. The working directory is called Demo Package. It's a subdirectory of where I just was, Essentials 3. And the directory comes prepared with the file structure that RStudio expects a package to have. We have a description file here. This is a file that contains the metadata of a package. We have a man folder. Currently it's empty, but stands for manuals. This is where you keep the help pages for your package. We'll have to make those. I have a namespace file, contains a different sort of metadata for the package. And I have an R directory. This is where you keep the R scripts that your package loads. And if we look in that directory, we see we already have the cityselector.r file and the mapviz.r file because I added them when I created this project. So now we're halfway to having an R project. We have everything organized the way it should be. But there's a number of steps that we need to complete to make this a working operational package. And to help us keep things organized, I've created a presentation that will sort of keep us on task. So why don't I open that, preview that. Here's our presentation in this window. What we're going to do to finish this package is go through these 7 steps. We'll go fill out the description file. I'm going to add the data set the package uses. We'll go finish writing our code, document the package, test it, check it, and finally build a package that we can share with other people. It sounds like a lot, and we're going to go through it pretty fast, but please keep in mind that this is doable, and it's actually fairly simple. So let's start with the description file, which is over here. The description file is very important because it contains information that your user uses to understand what the package does, but also information that R uses to load the package in a correct way. When RStudio puts a description file into your package at the beginning, it's not very informative. It's really just a template description file. So for example, the title is meaningless. I should replace this. We'll call my package city selector. I should list who wrote it. And then if I'm going to share this with anybody, I should let them know who to contact in case they have questions or things don't work. And I'm going to include my email address to do that. And then I should take some time to explain exactly what the package does, which I'm not going to do today because this is a webinar. I'll choose a license to distribute the project under. It's all open source, so Creative Commons works for me. And then there's one more field that's not in the template that you'll probably want to add to your package. In this case, you got an imports field or a depends field. Go add depends. And what I'm going to list in this field is all the packages that my package itself depends on. So if you look at my code here, you'll notice I am loading different packages with the library command. This is the exhaustive list. And when it comes time to load this package on a user's computer, R is going to want to know these package names ahead of time so it can be sure that it installs and downloads them all for the user. So I'm just going to convert these library commands into a list of package names that my package depends on. Now, it might seem to you that I pulled this field out of thin air, depends. And also, you might think I should use the imports field instead, and I'll go get into that. But there's a lot of wisdom or knowledge about how to write packages that I have. I've written a few packages, and this is just the sort of knowledge that you'd acquire by reading the book that I mentioned earlier. Hadley's book, R Packages. All right, so now my description file is ready to go. I'm going to close it. We don't need to worry about that anymore. I'm also going to close the namespace file because we don't actually need to fill out the namespace file. As we complete the steps over here on the right, the namespace file will take care of itself. RStudio will take care of it for us. Next thing we should do is add the data for our package. So my working environment right now, it's clean. If I want to save my data set into the package, I'm going to need to load the data first into R so I can use it. So let's go find that data again. It's over here in Essentials 3. It's called Central Florida CSV. Go open that. Same process as before. I'm still going to use the name CFL because I wrote my city selector function to use that name. Strings still not as factors. So now I have the data here in my local R session. If I want to save it in my package, the way to do that is to create a new folder in my package named data. R will expect the data sets to be saved in a folder named data subdirectory. And then I'll just save it using the save command in R, which creates an R data file. And I'll tell R to save it in the data subdirectory. In this case, I'll call it cfl.r data. So R saves it. If we look in this directory here, we see there's our file. So now our data is saved in the package as well. You can see we're already on step 3, writing and polishing our code. My code already works because I took the time to write it before I made the package, but you can imagine starting with your package structure and then writing the code there, knowing from the very beginning that this is going to be a package. And also, you can imagine saving some code into your package like I did just here, and then wanting to change it. For example, there are a few things I should change. When you save code in a package, you don't want to call library like this. That's what the description file takes care of. So I could remove these library statements. And then the next thing you can imagine is you'll want to test your code to make sure it works. In fact, if you're writing this from scratch, you'd want to test your code very frequently until it's finished to make sure it does exactly what you think it's doing along the way. If I wasn't writing a package, I would test this code very simply by sourcing it or copy and paste it into the command line. When I do that, it saves a global copy of the function in my global environment. Save the city selector file too. And then I could test these functions and see if they work. I could run city selector. And I already have a problem, and that's because I haven't in my local session run all the things like Library Shiny dashboard, Library leaflet, and dplyr. But now I could test my code like I was working at the command line. Notice here in this one, I have these black dots in here for the city locations. Let's pretend I want to make a slight change. I want to make those red. I could go back to my code and I could do that. Somewhere in my code, here it is. This is where it makes them black. I'm going to make them red. I'm going to save that. Now, when I create this package and distribute it, whatever I have saved in these files is what the user's going to get. That's going to shape how their package works. But if I come down here to test my code to see if it's still working, I get these black dots. The change hasn't come through. And I just show you that to illustrate that when you start saving your code in the global environment, that's the code that R is going to use. But that's not necessarily the code that your user is going to get. So if you use this workflow, there's a real shortcoming here. You might be working with code that the user doesn't see. It's not in your package at all. And that would create the possibility for errors. It's much better. Let me just erase all these things. So instead of treating the command line like you would when you're writing general code, to treat the scripts that you're writing as if they came from a package. Once you've set your package up using the new project package directory, RStudio adds a build tab to your project. You won't find this unless your project's already a package. But the build tab contains plenty of tools that are useful for developing your package. And the first tool we're going to look at is under the More menu, and it's called Load All. Whenever you click Load All, RStudio will load all of the functions and the scripts that are saved in your package. So I click Load All, and it loads my scripts as if they were a real package. If I look over Environment, those functions don't show up here. They're not being saved in my global environment. They're being loaded as if they were coming from a package. And I could use those functions here. It's like Run City Selector. And now my dots are red because it's using whatever I had saved in the R script saved in my package, which at the moment says the dots should be red. Load all is something you'll use very often as you complete and polish the code in your package. And you might not want to go to the build tab each time you want to use it. And that's okay. There's a keyboard shortcut built in to call load all. And it's very simple to remember. It's Command-Shift-L, L for load all if you're on Mac. And if you're on a PC, it's Control-Shift-L. In fact, there are keyboard shortcuts for all the steps we're going to look at today. And they're all use the same format, Command-Shift plus the most relevant letter to what you're doing, with one slight exception. Let's assume now that you've written the code and you got it the way you want it, as I have this code. I don't want to make any more changes. I just want to finish making my package. So what's the next step? The next step would be to document our functions. You don't want to give a package to somebody and not explain to them how the functions work. You want to create a help page for each function in your package and even your data sets that they could use if they get stuck. Now let's pause for a moment and leave the package that we're working on and look at our complete package, the city selector package. This is one I made ahead of time and it's already finished. And the reason I want to look at that is because it demonstrates how help pages occur in R. Inside its manual directory, there are 4 files. They're all .rd files. These contain the help pages for the different functions in my package. So I could open maybe the help page for city selector. This is what the .rd file looks like. .rd is a file format that stands for R documentation. The format is very similar to LaTeX, and R uses it to create help files. You can see that if you open a .rd file in RStudio, or if you save a file with the extension .rd, RStudio recognizes it. It applies syntax highlighting. It gives you a spell checker. It also lets you preview what the help page that this file creates will look like. So I could click preview here, and I'll see in the help pane, the output of this .rd file. If I wanted to, I could write all my help files from scratch in the RStudio source editor using these features to make my experience a little nicer. But I wouldn't recommend that you do that. I don't think anyone should write RD files from scratch. And there's a reason for that. If you look at how the package is set up, we have our R code in this R directory. We have our help files in the manual directory. And during the life of this package, people might find bugs. It's a possibility. Or I might think of a way to improve my code. And when it's time to fix the bug or improve the code, I'm going to go to the R directory, open the function I want to fix, make my changes, and then, if I remember, go to the manual directory and update the help page to describe that. But if I don't remember to do that, it's very easy for the help page to get out of sync with my function. And you always want to keep everything in sync. So there's actually a better way to create your help pages. And that's what I'm going to show you now. To do that, I'm going to go back to the package we're working on, demo package. It's the package in progress. I'm still working in the demo package project, so everything's keyed in the demo package. This is the script from demo package for city selector and for map viz. If we look at the manuals for demo package, there aren't any. We're about to make those. The improved way to create help pages in a package uses a package in R called Roxygen. And Roxygen is built into RStudio. RStudio can apply the Roxygen package to create help pages for you from your code if you tell RStudio that that's what you want to do. That's what we want to do. That's what I recommend you do. And that's what Hadley explains doing. To use Roxygen in RStudio, go to Tools, Project Options, Build Tools, and then click the button that tells RStudio to generate documentation with Roxygen. You don't need to configure this, but if you get very familiar with Roxygen, you might do that. Then click OK. Now RStudio knows that I intend to create my help pages using the Roxygen package. RStudio checks whether Roxygen's installed. I think it might automatically become installed with the IDE. And it's all set up to use Roxygen now. I just need to put the information that Roxygen needs to make my help page into my code. This is how the Roxygen system works. You insert code comments in front of each function that you want to document. When it comes time to release your package, RStudio will run Roxygen on your files. Roxygen will find those code comments and use them to create your help pages. The code comments look a specific way, and the best way to get started writing them is to just insert a template Roxygen comment in front of each function. There's a way to do that. This last keyboard shortcut here, Command plus Alt plus Shift plus R. If you click on the name of a function and you type that command, so now I'm typing Command Alt Shift R, RStudio inserts this Roxygen skeleton here. This is what Roxygen documentation looks like. It occurs in the .r file that you define your function. It takes place right above the function, so if you make any changes to the function, it's very easy to change the Roxygen comment. Every line in your Roxygen comment begins with R's commenting symbol, the hashtag, followed by an apostrophe. This double symbol here alerts Roxygen that this is a line of comments that it needs to use to build a help file. The help file that it builds will be the help file that corresponds to whatever function comes immediately after the last comment. Now this is an uninformative template, so it's my job to finish it. I should give my help page a title. This one I'll call map viz. I could add as many paragraphs that want to appear in the help page as I want, so I could say something like, map viz does this. Keep in mind that, so on. If my comment goes way off the side of the page, I could use RStudio's reflow comment shortcut, and shift, which is Command Shift / on a Mac, and it'll wrap it around nicely. But then the remainder of your Roxygen skeleton that you need to focus on will consist of these @ tags. The @ tags are how you tell Roxygen what goes in specific parts of an R help page. If you look up an R help page, you'll notice that there's almost always a section that explains the inputs that your function takes and the outputs that your function returns. There are also other sections, and you can insert as different types of Roxygen tags into your comments as you like to create the different parts of your help page. The skeleton automatically inserts a param tag for each input for your function. So notice this function takes X, takes radius, and it takes color. You should tell Roxygen and your users what those things should be. X should be a data frame. In this case, it needs to have a lat and a long column. You could guess what those stand for. Radius is an R expression that controls, in this case, the radius of the markers. And then color is the color of the markers, which in this case should be a character string. The return tag tells or puts into your help page a description of what the function returns. Here, this function returns a leaflet data visualization. And then export tells RStudio that it should include this function into the namespace file of your package. But more generally, what export means is that your users should have access to this function. You don't need to give your users access to every function that you put in a package. For example, some functions, like here my interval scale function, is only ever really used by the city selector function. I like that my user can call city selector, but there's not a good reason for them to call interval scale. And one day I might want to come back and completely change how interval scale does its job. If I don't let my users use it, then I won't ever have to worry that changing interval scale will change their code or break their code. So when I put the Roxygen skeleton in here for interval scale, I might take out the export command so they don't actually get to use this function. Any function in my package that uses it will find it no problem, but users won't get to use it. You don't have to worry too much about that. And then finally, after the examples tag, you could write example code that shows people how to use your package. For example, this code would work with MathViz. I'm going to remove the examples tag here because R will actually run your examples to check that your code works when it installs the package. And I'm just not really sure how that would play out if my code launched a leaflet data visualization. So for brevity's sake, I won't include any examples. All right, now I have a finished Roxygen command. Again, it probably seems like I relied on a lot of knowledge about packages to make this command. It is true that I did. If you don't have that knowledge, there are some places you could get it. If you want to write Roxygen comments for your package, you could go to the help window in the RStudio IDE. We actually have a Roxygen quick reference built into the IDE. It opens in the help page. It explains a little bit about how to write Roxygen commands, the different tags you could add in your command, and how they all work. Also, you could go to the help cheat sheets and open the package development with DevTools cheat sheet. It's the second cheat sheet here. This is accessible from inside the RStudio IDE, or you could go to the web page it takes you to from outside the IDE. And it's a whole cheat sheet front and back that goes through the whole package development process, and it spends a lot of time on the Roxygen package and how you'd use that. All right, say we went through and we finished writing the Roxygen comments for all of our code. Here I've only done it for one function, but for our purposes that will suffice. The next step is to actually document the code to tell Roxygen to take my comments and turn it into a help page. Let's take a look at our man folder directory right now. There's nothing in it, no help pages. If I want to turn this code into a help page, I could go to the Build tab, go to More, and click Document. When I do that, RStudio will use Roxygen to create a help page for any function that has Roxygen documentation comments in front of it. At the moment, it's only MapViz, so it creates the MapViz help page. Here's the RD file. I never had to make it. Roxygen made it for me. And when I load this package, it's going to make a recognizable R help page. If you don't want to go to Build and click More Document, then you can use the keyboard shortcut Command plus Shift plus D to document your package. So I'll go back here. Hit Command Shift D and it documents again. It's smart enough to know that I haven't really changed anything, so it doesn't change anything either. Let's close this. After you've documented everything in your package, you might consider writing unit tests, which are just tests that check to make sure that the functions in your package work the way that you expect them to. I'm not going to go through writing a unit test right now because it does take some time and it would be a bit of a detour. But if we did take a minute to check out the city selector package that I already made, go switch working directories to that directory. Got files. You'll notice that it has a directory of tests. And inside the directory of tests, there's some tests that I've written for this package. I'm using the test that package to create these tests. That's spelled T-E-S-T, T-H-A-T. If you want to know more about how to write tests or use test that, the best resource is the book that I mentioned earlier, How These Are Packages. There's a whole chapter on testing, explains how to do it. Once you've written your test, you could use the RStudio IDE to very easily test your package. The idea here is you create tests that define how your functions should work no matter what. If you go in and make any changes into your functions, when you're done, you run the test and make sure that they still work the way they're supposed to. You do that by going to Build, More, Test Package, or you can use the keyboard shortcut Command Shift T. When you test your package, you get output like this in your Build tab. What happens is for every test in my package that passes RStudio lists a dot next to it. So I pass this main test, all of my tests, in fact. But if I change one of these tests so it fails and I retest my package, I'll go hit Command-Shift-T to do that. You'll see that that first test isn't a dot. It's a number that corresponds to the error message that test that returned. It says something's going wrong here, and then I'd have a chance to go and debug it. And when I think I've debugged it, I'd rerun my test to make sure that worked. So that's how testing works inside the RStudio IDE. Let's stick with the city selector package to do the final steps. There's two more steps to developing our package. Really, all of our code is done. We've created our help pages. Our code works in the R directory. I've added the data set, and the description file is up to date. And in this case, I've even run unit tests. Our package is ready to go. But there's two things that I should do to make it easier for users to use the package. The first is I should check that the package works. And when I say check, I mean something specific. When you load a package into R, R runs some checks to make sure the package can be installed. Or when you send the package to CRAN, the most popular online R repository, they run a set of checks that make sure the package works too before they accept it. You could run those checks preemptively in RStudio to ensure that your package works before you try to disseminate it anywhere. The way to do that is from inside your package directory, run the check tab in the build command. Check will run a series of checks that check for the most common failure modes for R packages. Each line here is a check, and every time one ends with OK, that means the package passed. It takes a little bit to run. R is checking for quite a few things. And then when it's finished, it'll give you a message that tells you whether or not your package passed all of the checks. So my package did pass. It says R command check succeeded. It did find two notes. If your package fails, you'll notice that it found more than notes. It'll say it found a certain number of errors or warnings or notes. If you get an error or a warning with your R command check, you need to fix that. If you get a note, you may or may not want to go in and see what the note's about and fix it. Think of notes as optional fixes. Once you see how many errors, warnings, and notes you have down here, you go through the different checks and see which ones return the errors, the warnings, and the notes. So for example, this one returned a note. It's checking my code for possible problems and didn't find some visible global bindings of different things. This is something I should probably go back and fix. That could cause trouble later. This is why I had used depends instead of imports, for those who are following that debate. And then there's another note about other things that aren't imported from. But there's no warnings or errors, so my package won't fail catastrophically if I tried to load it. Usually, you go through the check a few different times until everything's working. And then you feel confident that you have a package you could share and your users can use with no problems. At that point, it's time to build your package. If you want to build and load your package on your own computer, you can do it by clicking the Build and Reload tab. So once you create that file structure for your package that R recognizes, R builds that into a compressed format that's easy to load into an R session. And that's what building means. And there's a number of different formats that R can turn it into and then load into its R session. So there's a number of different ways to build your package. But Build and Reload is the simplest compression, and then it loads it into your package library just as if you download it from CRAN or GitHub or wherever else. So when I click Build and Reload, it's going to build and install my package into R. And it's also going to reload the package by calling library on it, so I can start using it and testing it. So called library city selector on my package. Now here I could, run city selector. In this package, I didn't make these red, so they're still black. It's fine. There are two other ways you could build your package, and these are ways that you would use if you want to email the package or share it with somebody. So let's go to Essentials 3. This is city selector is my package directory, and I'm putting my view right here so I can see what happens when I run these two commands. You could build a source package. It's just a compressed version of your package saved as a gzip tarball. Clicking Build More, Build Source. RStudio is going to build that package for you, and it's going to save it in your directory. Here it is down here. This is the saved file. So I could email this to someone and they could install it from the command line with rcmd install. And then I could do something similar with build binary package, which would actually compile code and optimize the package if I had compiled code in there for my operating system. So this would be the binary for Mac OS. Now this is saved down here too, which I could share. The easiest way to share your package is probably to put it on GitHub That's where we put the development versions of our packages. And if you want to host a package on GitHub, you actually don't need to use this build step. You could just take your directory as you have it, files, and store that in your GitHub repository. So your GitHub repository would look like this inside of my package directory. And then users could download it with the function install GitHub from the DevTools library. As the arguments install GitHub, they put your GitHub username. So for example, I could install a package that RStudio made, and then they put the repository name of the package they want to install. So we keep the development version of the Shiny package in the Shiny repository of the RStudio GitHub account. And if I were to run this command, either use 2 colons or load the DevTools ahead of time. The command itself will fetch those files, build the package, and install it into my system library. And then I would have the development version of Shiny, so you could see exactly what our developers are working on for the next version of Shiny. And in this case, something's not going exactly right. That could be because I'm using the preview version of the IDE, or the latest change to Shiny isn't ready for the stable version. All right, so let's wrap this up, for closure's sake, by opening this presentation, previewing it, and verifying that we have in fact gone through all the steps of creating a package. We've finished the description file, we added our data set, we've finished writing and testing our code with load all. We documented it with our help pages. We used document to turn our Rockstudent comments into help pages. I showed you how to use tests. We checked the package, and then we built it into several formats that you could share with people. And then I discussed that you could just take the package directory itself and put it on GitHub. It's a very easy way to share your package. That's all it takes to build a package in RStudio. The features are built into the GUI, and there's these keyboard shortcuts that speed up the process as well. Like I said before, building a package is not as hard as you may have imagined, and it's certainly not something that you should leave just to the most experienced expert R users. Packages are for everybody.